Hey guys, hope you're doing well today. This video, I'm going to be doing some testing with my QuickSpot 2. This is from HTP. So I've used this to do mild steel, galvanized steel, and stainless, but I've never used it on aluminum. And they don't have a profile for it. So I contacted them and they've given me some advice on how to use this with aluminum. So I've got a job coming up where I'm hoping to use this. So follow along and we'll get this done. So the spot welder makes things so much easier in the right application. So what I've got for testing, I made me some little aluminum coupons. These are 80 thousandths, but what I've been told is you can't directly weld these with this QuickSpot. So what I've done is I've made some stainless pad, and these are 45 thousandths. So what you want to do is have your aluminum and sandwich it in between the pads and spot weld it like that. So on the spot welder we have 3 settings. We have pulse and normal, and I guess these will be our heat input. So this is the thickness of metal or combination thereof. So from 0.6 millimeter all the way to 2 millimeter. So the way I interpret this, you could do a total of 4 millimeters of thickness. And then if you need to tweak it, you got your duration, your time setting right here. You can increase or decrease the time on that. So the jaws I'm using are the standard 4-inch ones that come with it. And they sell several different types of jaws also on their website. Since my aluminum is pretty much 2 millimeters, we're going to go ahead and start there. We're going to leave our time on default, and we're not going to do pulse. So we're going to start there. Test number 1. So stainless, aluminum, aluminum, stainless. Okay. So the stainless did stick, but it pops off. All right. Okay. It actually looks pretty solid. I'll put this in the vise. I'll do a couple of these and we'll put it in the vise. And what we want to see is this weld not breaking, but actually tearing the metal around it. So this is going to be number 1. So we're going to the next level. So the goal is to not do so much damage to the stainless. So we're going to go in a different spot on the stainless. Okay. All right. A lot less damage. The stainless did not stick. Well, it stuck on. It didn't stick as bad. So the first try and second try, so a little less damage. Okay. That's still pretty solid. Happy with that. It does look, the weld area does look smaller. This is part number 2. It does look smaller from here than the first piece. So we're going to leave that alone and we're going to try pulse and see what happens with that. Okay, this is test number 3 with pulse. Being sure to get on a different spot on the stainless. Spot on the stainless looks about the same. And it's stuck about the same. Okay, this is number 3. So honestly, it's look the same. It looks like there's a crack in there. So to me, that looks like a crack. But when we get it in the vise, we'll see how these hold up. So now I'm going to turn the heat back up. And then we're going to drop our time all the way down. We're going to leave it, we're going to turn pulse off. Got our sandwich made up. Okay. So it made us, it looks similar as to the lower heat setting with shorter time. The stainless is stuck a little less. So that weld area there looks about the same. So let's just see what happens. I've never tried this with just aluminum. Let's just see what happens when we try to do just bare aluminum. Okay. All right, that snapped apart, but let me turn the time up. I put the time duration in the middle and the high setting. Okay. Stuck to the jaws a little bit. Okay. So, for whatever reason, it was kind of hard to break apart, but I did break it apart. You can see how much it bent before it broke. But that explains why you can't do this without a backer. See if we can break these. I'm going to put this pretty close to the weld. Okay. That was on the default setting for time and temperature, non-pulse. So it completely ripped a hole in the metal. So there was zero failure on the weld. Very happy with that. This is weld number 2, where we turn the temperature down. Oh, that took almost zero effort. Okay, number 3, which I believe was pulse. It was the lower setting on pulse. No good. That snapped right off. And then test number 4 is where we turn the time down. Okay. So that ripped the metal out. So what that tells me is, so this material is just over 2 millimeters, which is right at 80 thousandths. So for this test, for the 80 thousandths aluminum, I'm going to leave it off pulse, the highest heat setting, and the duration, bringing it down made the stainless stick less, and it still seemed to be just as strong. So guys, I hope this little test helps you. If you don't have one of these, if you're doing any kind of sheet metal work, it's a great tool. It's a little expensive if you're just a hobbyist, but if you're a business, you need one of these. There's cheaper options, but you're not going to get the controls. You're not going to get your timer and your heat controls, and especially pulse. What this does is allow you to dial in your welds and get consistent welds every time. So once this thing is set up, every weld's the same, provided your metal's the same. So I highly recommend it. You can go to usaweld.com, pick one of these up. And if you would, give me a like and subscribe. And remember, you were created for a purpose. And we'll catch you on the next one.